D pi p pi bonds, also called as p pi d pi bonds. How to calculate them? How to identify them? So SO2 molecule, SO3 molecule, sulfur, two double bond O with one lone pair. Here double bond O, three members. In both the cases, sp2 hybridization. Here also sp2 hybridization means trigonal planar geometry. Here one lone pair is there, so that bent or V or angular shape. Here exactly trigonal planar structure. Now sp2 means till one more p orbital available. So one more p orbital available, but two pi bonds there. Oxygen can have p orbitals only, but not d orbital. Oxygen can have p orbital, but not d. So oxygen p orbital, sulfur's another p orbital, one p pi, another pi bond. Oxygen can use p only, but sulfur can use one p already utilized, another one d orbital, one d pi p pi. So total two pi bonds there. Out of them, one is p pi, another one d pi p pi. D with respect to sulfur, P with respect to oxygen. Or you can say P pi D pi also, but P with respect to oxygen, D with respect to sulfur. Then here sp2 over one more p orbital there. So one pi bond is p pi. Then other two pi bonds, obviously d orbitals of sulfur utilized. So two d pi p pi bonds. Out of the three pi bonds, one is p pi, two are d pi p pi. Further, more clarified information, explanation about SO2 and SO3, how p pi, d pi p pi. Hybrid orbitals can form sigma bonds. So sulfur outermost electron configuration 3s2, 3p4, 3s2, 3p4. This is ground state configuration. Now in this case, it cannot form four bonds here, four covalent bonds appearing, 1, 2, 3, 4. Now for giving four bonds, it is exciting. It can utilize the d orbitals now. 3d this is, 3s, 3p. Now one electron excited to d orbital. Now being sp2 hybridization, how many sigma bonds there in SO2? One is sigma, another one pi. One is sigma, another one pi. So two sigma bonds there. So sp2 hybridization, hybrid orbitals involved in sigma bond formation, two sigma formed. One is lone pair, two sigma bond formed. Then this member p orbital, p pi with oxygen's p orbital, p pi. And this member d orbital, pi bond formed, d pi, p pi. Hybrid orbital can form sigma bonds. So remaining are pi bonds. In this way, p pi, d, one p pi, one d pi, p pi. Then similarly, in case of SO3, so here also excitation occurred. This is first excited state, and here no lone pair there, you have seen there. Two electrons excited, second excited state. Now, how many sigma bonds there you see once? Sigma, sigma, sigma. Pi bond, pi bond, pi bond. 3 sigma, 3 pi. So 3 sigma required. Na? sp2 hybridization again. All are sigma bonds, 3 sigma bonds. No lone pair. Then what about this member? This can give p pi, oxen p pi. Then these two can give 2 d pi p pi. In this way, d pi p pi bonds you can identify. Simple way, you can start like this: sp2, other one p. Here sp2, other 2 pi bonds there, one p pi, other 2 pi bonds are d pi p pi. Similarly, PO4 3 minus first. PO4 3 minus. Phosphorus sp3 hybridized. P double bond O with 3O minus. So one pi bond is there here, phosphate ion. Which type? sp3 means no p orbital left. All the p orbital utilized. Hybrid orbital can form sigma bonds only, 4 sigma there and 1 pi. What is that pi bond? P pi, d pi or d pi? So p orbital since not available, only d orbital it can utilize, and oxen automatically p orbital it can utilize. 1 pi bond, that is of d pi p pi type. Then ClO2 minus, ClO3 minus, ClO4 minus. Calculate number of d pi p pi bonds, or if any p pi bonds there, explain. Oxo acids of chlorine sp3 hybridized are their anions chlorine sp3 in all these cases. Cl with double bond O minus, 2 lone pairs are present. Here double bond O minus with 1 lone pair. Here no lone pair, O minus, double bond O, double bond O, double bond O. Now this is of bent shape, pyramidal shape, ClO3 minus. This is tetrahedral shape. So everywhere sp3 is there. So sp3 hybridization means no p orbital available. Whatever the pi bonds appearing, all of them are d pi p pi. Here 1 d pi p pi. Being no p orbital available, everybody having sp3 hybridization. Then here 2 d pi p pi. And here 3 pi bonds there, all are of 3 d pi p pi. Oxens p orbital, chlorines d orbital. In this way you can directly answer. Then last, xenon compounds. Whatever the pi bonds present in xenon compounds are of d pi p pi. All pi bonds in all xenon compounds are D pi p pi type. Directly you can learn this point. All pi bonds d pi p pi in all xenon compounds. Hybridation only reveal you this thing. XeO3 sp3 hybridation with one lone pair. Three sigma 3 pi. All the 3 pi bonds are of d pi p pi. This is pyramidal structure. XeO4 xenon. Tetrahedral structure sp3 hybridation again. Four sigma 4 pi. All the 4 pi bonds are of d pi p pi, being sp3, no p orbital available there. XeOF2 Xe is of sp3d hybridation. sp3d. More electronegative atom, fluorine prefer to occupy axial position here. Two lone pairs in equatorial position. One pi bond is there. So 3 sigma 1 pi. That one pi bond is of d pi p pi. This is bent T shape. This is tetrahedral here. Next, other compounds are there, last xenon compounds. XeOF4 and XeO2F2. Xenon here sp3d2 hybridation. Fluorine are in square planar position. Lone pair and double bond axial position. 1 2 3 4 5 sigma 1 pi. That 1 pi bond is of d pi p pi. Why? Because all the p orbitals already utilized. Then the structure is square pyramid. Square pyramid. XeO2F2 sp3d hybridation. Here also no p orbital left. That's why I am telling all xenon compounds, all pi bonds are of d pi p pi. But how many there you should notify it. So XeO2F2 TBP geometry, equatorial position like this, and fluorine prefer to occupy axial position. Here only fluorine in a square plane. So here again axial. Now 1 2 3 4 4 sigma plus 2 pi bonds there. Both the pi bonds are of d pi p pi. Why? Because no p orbitals available. And this structure seesaw, folded square or distorted tetrahedron structure.